Please explain vacuum tubes and transistors in detail in an easy-to-understand manner. Vacuum tubes, which were invented by Lee de Forest in the United States in 1906, are electronic components. They are constructed with a glass envelope, maintaining a vacuum inside, and contain 3 electrodes: filament, grid, and plate. Vacuum tubes operate on the principle of electrons emitted from the filament being attracted to the plate due to an electric field generated by the grid. Applying voltage to the grid increases the strength of the electric field, causing more electrons to move to the plate. Conversely, reducing the grid's voltage weakens the electric field, leading to a decrease in the electron flow to the plate. Vacuum tubes have the following advantages: high voltage amplification capability, excellent frequency response. However, they also have several disadvantages. Difficult to miniaturize. Generate significant heat. Short lifespan. Transistors, on the other hand, were invented by John Bardeen, Walter Brattain, and William Shockley at Bell Labs in the United States in 1947. They are semiconductor devices, typically connected to electrodes on materials like silicon or germanium. Transistors operate on the principle that when current flows into the base, it controls the flow of current from the collector to the emitter. Increasing the current into the base results in more electrons moving from the emitter to the collector. Transistors offer the following advantages: easy to miniaturize, generate less heat, longer lifespan. However, they also have some drawbacks. Challenging for high-frequency amplification. Difficult for large current amplification. Vacuum tubes and transistors are both electronic components used for amplifying or transforming electrical signals, but they differ in terms of materials, structure, operation principles, and pros and cons. Vacuum tubes excel in frequency response but are challenging in terms of miniaturization, heat generation, and lifespan. Transistors are easy to miniaturize, generate less heat, and have a longer lifespan but face difficulties in high frequency and large current amplification. Vacuum tubes have found applications in fields like audio amplifiers, radios, and televisions where frequency response is crucial. Transistors, on the other hand, are used in various fields, including computers, mobile phones, and household appliances, and their usage continues to expand with the advancement of electronics engineering. In conclusion, vacuum tubes still have a place in certain fields, although they lag behind transistors in terms of miniaturization, heat generation, and lifespan. Transistors have broadened their scope of application across various fields with the advancement of electronic engineering. So, in the case of memory semiconductors, where and how are various information such as images and sound stored? Memory semiconductors store information using the presence or absence of charge. If charge is present, it is stored as 1, and if there is no charge, it is stored as 0. By combining these ones and zeros, digital signals are created, which are used to represent various types of information such as images and audio. Memory semiconductors can be broadly categorized as SRAM, static random access memory, and DRAM, dynamic random access memory. SRAM uses the retention of charge in capacitors to store information, while DRAM stores charge in capacitors and periodically checks if the charge is maintained to store information. Here is how images and audio information are stored in memory semiconductors. Images. Images are composed of points, which we refer to as pixels. Each pixel has color and brightness information, which is converted into digital signals for storage in memory semiconductors. These digital signals are represented as ones and zeros and are stored in the memory semiconductor. Audio. Sound is made up of vibrations, represented as waveforms. These waveforms come in various shapes and sizes and are used to represent audio. When storing audio in memory semiconductors, these waveforms are converted into digital signals, where 1 and 0 represent different aspects of the sound, and they are stored in the memory semiconductor. The method of storing information in memory semiconductors includes sequential access. Sequential access involves accessing information stored in memory semiconductors in a sequential order. Direct access. Direct access allows for accessing stored information in memory semiconductors directly through addresses. When storing image and audio information in memory semiconductors, the direct access method is used because image and audio data are not stored sequentially. The capacity of memory semiconductors refers to the amount of information they can store. Larger capacity means the ability to store more information. The speed of memory semiconductors refers to how quickly they can read and write information. Faster memory semiconductors enable quicker data retrieval and storage. When storing image and audio information, memory semiconductors with large capacity and fast speed are preferred. All types of information are not static but dynamic. So how can dynamic information be stored and replayed from moment to moment? Various types of information are dynamic, not static. To store and reproduce dynamic information, a method for representing information that changes over time is necessary. Here's how video and audio information are stored and reproduced. Video. Video consists of pixels with changing colors and brightness over time. To represent this, the colors and brightness of pixels need to be converted into a digital signal that changes over time. This digital signal is compressed using video codecs. Video codecs are algorithms that allow you to control the quality and compression rate of video. Compressed video is stored as video files. When playing video files, video players use the codecs to decompress the video. The decompressed video is then displayed on a display device. Audio. Audio consists of waveforms with changing shapes and amplitudes over time. To represent this, the waveforms need to be converted into a digital signal that changes over time. This digital signal is compressed using audio codecs. Audio codecs are algorithms that allow you to control the quality and compression rate of audio. Compressed audio is stored as audio files. When playing audio files, audio players use the codecs to decompress the audio. The decompressed audio is then played through speakers. This is how dynamic information can be stored and reproduced. Recently, research has been conducted on more efficient ways to store and reproduce dynamic information using artificial intelligence. AI is being used to analyze dynamic information and develop methods to convert it into appropriate digital signals.